Hello everyone, now consider the next chapter, line regression analysis. First consider the concept of regression. The line of regression is the straight line giving the best estimate of one variable. If there is a relationship between two variables x and y, there is one equation. The regression analysis or line of regression is nothing but the straight line which gives the best estimate or best value of one variable for the given specific value of the other variable. Line of regression, there are two types: line of regression of y on x and x on y. Y on x gives the best estimate value of y for specific value of x, and x on y is nothing but gives the equation which gives best estimate value of x for the given specific value of y. Now consider the equation of line of regression of y on x, nothing but y minus y bar is equal to r into r is nothing but Carl Pearson's coefficient, correlation coefficient, which we have studied earlier in the earlier chapter. R into sigma y, that is standard deviation of y. Sigma y square is nothing but variance of y. Sigma y upon sigma x into x minus x bar. This is the equation of line of regression of y on x. And similarly, for x on y is nothing but just replace y by x here, and r as it is, x minus x bar is equal to r into sigma x upon sigma y, y minus y bar. Now angle between regression line, theta 1, there are two angles, one is acute angle and other one is obtuse angle. Theta 1 is nothing but acute angle tan inverse of this sigma x into sigma y upon sigma x square plus sigma y square into this is multiplied by 1 minus r square upon mod of r. Okay, modulus value of r, the positive value of r, that means this is the acute angle. And if you reverse the numerator, r square minus 1 here, except the rest of the terms as it is, we get obtuse angle. Okay, now coefficient of regression, that is byx, is nothing but covariance of xy upon sigma x square. Bxy is nothing but, there are so many formulas for bx and bxy. In particular examples we will study that. Covariance of xy upon sigma y square of bxy. There is one theorem of regression coefficient. The correlation coefficient, that is r, is the geometric mean between these two regression coefficients. Okay, this is just a statement. Now consider this. Note, u is equal to, let u is equal to x minus a upon h, v is equal to y minus b upon k. In this case, rxy, that is Carl Pearson's, becomes ruv. Okay, and rxy sigma x becomes k upon h, this k and this h upon h. Ruv, these two are same, into sigma v upon sigma u. Variable gets changed. Okay, if we change the origin and scale here. Now consider the first example, depend on this. Calculate coefficient of correlation, that is we have to find out r and obtain the least square regression line of y on x. We have to find out regression line equation of y on x for this following data. X are given, y are given, there are total 9 observations, that means n is equal to 9. Obtain y, which should be corresponding to average to x is equal to 6.2. That means from above regression line we have to just put value of x is equal to 6.2 and we have to calculate y. That's it. Now consider the x column. We have to make these such columns, x columns, y columns, and we have to change the origin and scale also. X minus x bar. What is x bar? That is the summation of all x divided by 9. Okay, that means 5. It comes to 5 here. Summation x bar is nothing but summation x upon n. Y bar is equal to summation y upon n. Okay, therefore x minus x bar is 5, y bar is summation y upon n, that is 9. Addition of all these things, average of this all y numbers, okay, divided by 9 becomes 12. Y bar is 12, x bar is 5, and x minus x bar column is this x minus 5, 2 minus 5, 3 minus 5. This is addition of u is 0. V, y minus y bar, This 9 minus 12, 8 minus 12, 10 minus 12, and so on. Addition is 0. Again make u square, this column square, this column square here, u into v, these two columns multiplication. Okay, now u is here. What is u? X minus x bar upon 1. Nothing is there, division means 1 is there. That's why comparing this with this, x minus a upon h, we get a bar is nothing but x bar and h is nothing but 1. Here also y minus y bar upon 1, v is equal to y minus y bar upon 1. That's why k is equal to again 1. N is equal to, obviously, number of observations is 9. Okay, x bar and y bar are this. And some u bar is nothing but summation of this u divided by number of observation, like x, that is 0 only, and summation of v is again 0. That's why v bar, mean of v bar is also 0. Okay, now all this we just calculated. Now put the value of all these things in r first. R is nothing but this is the formula. You have to mug up this formula, put all these values in the equation. We get answer is 0.95. Okay, now second question is where to find out regression line of y on x. Now regression equation of regression line of y on x is given by this. Okay, now here we have to find out this first. R sigma y upon sigma x is nothing but, this is the definition, r sigma x y upon sigma x is k upon h. Here in this case k is and h are same, 1, and r u v into sigma v upon sigma u. This is the formula. Okay, what is sigma v? 1 upon n summation u v square, this is v square, and v bar square, this is u square, u bar square. Okay, and both addition is 0, that's why it comes only r. Okay, hence addition of this v and u are 0, the u bar and v bar are 0, therefore this comes 0, this comes 0. This addition same, 60 divided gets cancelled, 1 upon n also gets cancelled, only r remaining. R is equal to 0.95. Value of this is 0.95. Put this value in this equation, we get y minus y bar is equal to 0.95 into x minus x bar, which is equal to y minus y bar value, this is x bar value. Rearrange for y, we get this equation of regression line y upon x. Again we have to find out when x is equal to 6.2. Put x is equal to 6.2 in the above equation, we get y is equal to 13.14. Okay. Now consider this second equation example. Obtain equation of regression line y on x and x on y. You have to find out both equations. Here x and y are given like this. Total n observations are there. 10 observations are there. Therefore n value is 10. Here x values are here, y values are here. Now we have to find out regression line of y on x. You can find out by this way or in this way also. Okay, this is x line, this is y line. Suppose dx is x minus x bar. In earlier case we call dx as u only. Okay, you can use this formula also. This is easier one to find out sigma x and sigma y also. Okay, dx is x minus x bar. X bar is mean of x bar, x, that is summation of x upon n. This addition 900 divided by 10 is 9, and y bar is summation y upon n, that is 700 divided by 10, that is 70. This is a dx column, this is dy column. Addition of dx and dy, there is a difference is 0, and square of this two columns. Okay, and multiply of this two column, dx into dy. Okay, now put all this equation in first. X bar and y bar we just calculated, byx, which is equal to summation dx dy upon summation dx square. This is one formula for byx. Summation dx dy is 3900 upon summation dx square is this 6360. Answer is this 0.6132. Again bxy is again similarly, just replace x by y here, we get answer 1.361. bxy by x. Now put we have the equation of regression line y on x formula is like this. Okay, this is also second formula. This is the other formula. Now put all this value of this x bar, y bar and b by x, we get this equation, y on x. Similarly, x on y is just replace x y by x here, we get x minus x bar is equal to bx by y minus y bar. Put all these values in this equation, we get x is equal to this equation. This is the other regression line on of x on y. Okay. These are some homeworks. This is the first homework. Answers are given here. This is the other homework. Here hint is given. We have to find out y on x and x on y equations are also Carl Pearson's correlation coefficient, that is R. For that, take dx is equal to only u and dy is equal to v. Okay. Or you can use the earlier formula. Okay. Consider next example. On each of the 30 items, there, that means here is equal to 30. Summation x, summation y, summation xy, summation x square, summation y square are given. We have to find out product moment correlation coefficient. Also slope of the regression line of y on x. Okay. Also find Carl Pearson's correlation coefficient here. Okay. Now product moment correlation coefficient is nothing but r, rxy. Okay, which is equal to n into summation. This is the formula for product correlation coefficient in terms of summation x and summation y. Put this all this value in this equation, we get answer is 0.856. And byx is the coefficient of regression. It's just coefficient of regression, and where equation is equation of regression y on x. Okay, this is the coefficient of y on x, is nothing but this is the formula for y on x. Put all these values above in this equation, we get answer for byx is equal to 1.1028. Again, Carl Pearson's coefficient is given by r square is equal to byx into bxy. Similarly, calculate bxy by usual method and put this value both in this equation, we get r square. And take a square root on both sides, you get r. That is Carl Pearson's correlation coefficient. Now this is one more homework. Okay, this is the other homework. Hints are also given. You can solve it. Okay. Now consider next point. Mean values, that is x bar y bar, from the line of regression. If the line of regression is given in particular example, we can find out the mean value, that is mean of x and mean of y, that is x bar and y bar, we can calculate. Consider these two line of regressions are given, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Comparing by the given example, given equations in the example, comparing these with these two standard equations and find out value of a1, b1, c1, a2, b2, c2. From these 6 values, these are the defined term, where x bar, mean of x is x bar is this b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. Similarly, y bar is like this. byx, that is coefficient of regression of y on x, is this minus a1 upon b1, and that of x on y is bxy is equal to minus b2 upon a2. And from these two, this is the definition of Carl Pearson's coefficient, r square is equal to byx, product of these two. Okay, now consider the equations. Line of regressions are given. Okay, these are the two lines. If variance of x, that is sigma x square, is given 9, we have to find out these three: mean of x and mean of y, correlation coefficient, that is r, and standard deviation of y means sigma y we have to find out. Okay, now comparing these two equations with these standard equations. Okay, here equations are 8x minus 10y plus 66 is equal to 0 and 40x minus 80y, and take 214 on this side minus, it comes to minus, okay, is equal to 0. Comparing these two equations with these standard equations to find out this constant, we get a1 b1 c1 as 8 minus 10 66, a2 b2 c2 as from these two equations, second equation. Okay, now put all these values first in x bar, this thing we get answer for x bar, that is mean of x is 13, mean of y is, put all these values in the equation, we get 17. Again we have to find out byx, second correlation coefficient, that is r. Before that we have to find out these two by using these two equations. Therefore put values of by byx is equal to here, we get 4 by 5, bxy is equal to minus b2 upon a2, from this we get 9 upon 20. Therefore r square is equal to product of these two, which is equal to 9 upon 25. Therefore r is equal to, take a square root on both sides, we get 3 upon 5, take positive value. Now byx is equal to r sigma y upon sigma x. Therefore put all these values in the equation, we get sigma y is equal to, solving this all these things, 5 gets cancelled, 3 gets cancelled, answer is only 4. Okay, now this is some second example. Write down, find correlation coefficient r, standard deviation of y on standard deviation of y. Okay, if the given thing is regression equation y on x is y is equal to x and x on y is 4x minus y is equal to 3. These two equations are given, regression equations, and moment of x about origin is 2. What is moment about x or at origin 2 is, let us see. Y is equal to x is given, it means take x on this side, minus x plus y is equal to 0, first regression equation, and 4x minus y minus 3 is equal to 0, second regression equation. Therefore comparing the earlier example, value of a1 b1 c1 and a2 b2 c2, we get these values using this equation. Okay, now we get, therefore from this equation byx is equal to this formula, put all these values, we get 1, bxy is equal to this, put values, we get 1 by 4. Okay, now put these two values in this equation, r square is equal to byx into bxy, which becomes r is equal to, take a square root, we get 1 by 4 square root, positive square root, that is half. Now moment of x about origin is nothing but summation of x minus about origin means 0, and moment is a square divided by n. This is the definition of moment of x about origin. Okay, about point comes here only. Okay, that means is equal to 2 is given, that means summation x square upon n is given 2. Now y is equal to x, therefore takes bar on both sides, that is mean on both sides, what we get, y bar is equal to x bar, and from second equation 4x minus y is equal to 3, take a mean on both sides, what we get, 4x bar minus y bar is equal to 3. Now solve these two equations simultaneously for x bar and y bar, or put here x bar value, y bar value is x bar, we get x bar is equal to 1 and y bar is equal to, as again both are equal, therefore both are 1. Now therefore sigma x square is equal to, now this is the formula for sigma x square, that is summation x square upon n minus x bar its square. This is a formula for standard deviation of x, we have already studied in earlier chapter. Now put all these values here, which we have just calculated, answer is 1. Therefore take a square root on both sides, sigma x becomes 1. Okay, also we have to find out sigma y. Now this is another formula for byx is equal to r into sigma y upon sigma x. Whatever the given things in the examples, we have to use those examples and correct, we have to find those corrected formulas for corresponding terms. Okay, there are more than one definitions or formulas for any term here. R has also different formula. Here sigmas are also have different formula. Depend on the examples given conditions, we have to use the corresponding formula. Okay, therefore now we are using this formula because these terms are given here. Okay, we have to find out this. Put all this value, we get sigma y is equal to 2. Okay, here some homeworks are there. This is first homework. The two regression lines. These are two regression lines. These two equations are there. Sigma x is given in earlier example. In earlier example, this is the same example. We have to find out r, sigma y and mean of x and y. This is the same example. Okay.